Okay, so we're going to look at a warm-up of density, which is a word that should be new to you in grade 9 math. So if I am trying to choose a number between 1 and 20, am I more likely to get an even number or an odd number? So take a second, pause the video, and try this out and see if you can figure that out. You more likely to get an even number or an odd number? Okay, so what you likely have done is you've probably created two lists. So I'm going to go, okay, I'm looking at my even numbers. What are my even numbers? So I'm going to write this in set notation. So I've got 2, 4, 6, 8, 10, 12, 14, 16, and 18. Oh, wrong bracket. And I've got my odd numbers. So I've got 1, 3, 5, 7, 9, 11, 13, 15, 17, 19. The one list looks longer because I've written it a little bit longer, but let's count. How many elements are in both of those sets? So when I look at my evens, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 elements. And when I look at my odd numbers, oh, and sorry, I missed one. There should be 20 in this set as well. So I'm going to erase this. Instead of 9 elements, I'm going to write that there are 10 elements in this set. And then how many elements are in my odd set? I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 elements. So am I more likely to get an odd or an even number? I'm going to say that they're the same. That they are both just as likely to happen as the other. Okay. If you chose the numbers instead from 1 to 10, are you more likely to get a prime number? So a prime number is divisible by 1 in itself, or are you more likely to get a composite or a non-prime number? Okay, so I'm going to give you a second to figure that out. Okay, so from 1 to 10, I've got divisible by 1 and itself. I've got okay, so I've got 3 because 1 is not a prime number. 3, 5, 7. And that is my list of prime numbers from 1 to 10. Because 2 is divisible, oh, I missed one. 2 is divisible by 1 in itself. So I've got 2, 3, 5, and 7. And my composite numbers, or my non-prime numbers, 1 is not really made up of anything, so 1 doesn't count as composite or prime. 2 is in that list, 3, so 4, 6, 8, 9, 10. So when I look at this list, there are 4 elements in my prime list, and there's 1, 2, 3, 4, 5 elements in my composite list. So I am more likely to get a composite number than a prime number if I randomly choose a number from 1 to 10. Okay. What if you choose from the numbers 1 to 20? Are you more likely to get a square number or a prime number? So I want you to try to pause the video and I want you to write out those lists. Okay. So I'm going to start with prime because we had them before. So we had 2, 3, 5, 7. We've got 11, 13, 17, and 19. Those are my prime numbers. Square numbers, so those are the numbers that if I, for example, went 1 squared, 1 is prime. 2 squared is 4. So 4 is a square number. 3 squared is 9, so that's a square number. 4 squared is 16. And then 5 squared is 25. That's too big because my list is only 1 to 20. So when I look at this list, I've got 4 elements. And here I've got 1, 2, 3, 4, 5, 6, 7, 8 elements. So am I more likely to get a square number or a prime number? In this case, I'm more likely to get a prime number because there are more of them between 1 and 20 than there are square numbers. If I randomly choose a number from 0 to 20, am I more likely to get a whole number or a natural number? So take a second and write those down. So if I look at my whole numbers are 0, 1, 2, 3. I'm not going to write them all down, but they go up to 20. My natural numbers start at 1, 2, 3, and then they go up to 20. So am I more likely to get a whole number or am I more likely to get a natural number? Well, in this case, I'm more likely to get a whole number, but not by very much. There is one extra element because both of these sets are the same, except for whole numbers include 0 and natural numbers do not. So I am more likely to pick a whole number because it is slightly larger than natural numbers. If I chose the numbers from 0 to 20, am I more likely to get a whole number or an integer? Okay, so if I look at whole numbers, they include 0, they go up by ones, and they're going to end at 20. My integers, and we actually represent integers with a Z, we've got 0, 1, 2, 3, up to 20. And these are equally likely. They're the same size sets. Equally likely. So they have the exact same number of elements. Integers are larger, but when I include negative values. If I randomly choose a number from 0 to 20, am I more likely to get a rational number or an irrational number? This one, hopefully you've pushed pause and tried this one and thought about this one really hard, because this one is a challenging one to think about. If I think about my rational numbers, remember they're my numbers that can be represented as fractions. So they're every single whole number plus anything that can be represented as a fraction. My irrational numbers are all of my numbers that they include pi, they might be like a square root of a number, but they're all the ones that have infinite numbers of decimal places. They are everything that fits in between our fractional values. So rational numbers, there is tons and tons and tons of these. They are, and we call these infinite because there's no way that I could list them all. Except irrational are infinitely, they also have infinite, but a larger infinite. Because there is much more values or many more values in this set than in rational numbers. So in this case, irrational numbers would be more likely to get selected. Okay. What we've actually been looking at is density of a number set. So density tells us how closely packed the numbers are in a set. A number set is more dense if there are more numbers squeezed into the same space on that number line. Think of it like this. If you're placing dots on a line, a dense set has lots of dots close together, while a less dense set has fewer dots with more spaces between them. So if I'm to go back through our examples, our even and our odd set have the same density because they both have the same number of elements in them. Where my composite set, because it has 5 elements compared to my prime numbers, my composite set is more dense. Prime numbers are more dense than square numbers. My whole number set is more dense than natural numbers because there is more of them. Where my whole number and my integers, when I'm comparing them between 0 and 20, are the exact same size. So in this example, they had the same density. I hope this helps you understand what density means.